Okay, so we went through sine, cosine, tangent. And at the very, very bottom, if you followed along with the notes packet, you don't have to, but if you did, at the very bottom, it starts talking about, well, what if you're trying to find an angle? So when you have the sine of an angle, then that's equal to the opposite over the hypotenuse. And usually we know yesterday, for example, we know these two sides and we're trying to find, or excuse me, we know one of the two sides and we're trying to find the other one. So we usually use sine, cosine, and then tangent when we're trying to find one of the sides. And so these three things help us find unknown sides. We know the angle and then one of these two. So we know 2 out of the 3, and then we use cross multiplying to solve. So what we don't know is, what if we want to do the opposite? What if we're trying to find an angle? And so when we're trying to find an angle, you would have to know 2 sides. And so what happens is you have to use sine inverse, and you're going to tell your calculator, hey, here's the opposite to hypotenuse ratio. What's the angle that has that relationship? When I'm looking for the angle and I've been told the adjacent side and the hypotenuse, then I'll choose cosine, but I'll do cosine inverse because I'm saying what angle has this relationship. So when you're using inverse functions on your calculator, which you'll see they're the second function. So like on your sine button, the second function says sine to the -1. And then for tangent, that's going to be if I know the opposite and I know the adjacent side ratio, then I can go ahead and find that angle. So for example, real quick before we get into what's on the notes packet, if I was supposed to find this angle, like this is the angle in question, and I knew this was a 7 and I knew this was a 12, your cat is like paying attention, I think, Steve.
Yeah.
So this is from the angle, you do the same thing as yesterday. You think, what side is this? Well, this is the opposite side from that angle. It's across from it. What side is that? That's the hypotenuse because it's across from the 90. So because I'm still thinking SOHCAHTOA, but in this problem, I have opposite, I have opposite and hypotenuse involved. I'll be using the sine, but instead of using it like regular, hey Kelsey, I'll be doing sine inverse of the opposite over the hypotenuse. So you already know the sides and you're asking your calculator to help you find the angle. Now, sometimes on the worksheet, it will write this as a fraction. So they would have written 7/12. I'm just doing that into a decimal as 0.5 you're repeating. So this question is the same as saying, what's the sine inverse of 0.5833? Both are asking for you to find the angle that would have that relationship as an opposite over hypotenuse relationship. So on your calculator, just to practice that, go to your regular calculator screen, do second sine, and then tell it, I have an opposite of over hypotenuse ratio of 7/12. And when you do that, you should get about a 35.68 degree angle. So that means that this angle is about 35.7 degrees. Are you getting that on your calculator, just to know that you're doing that right? Okay, so let's take a look at the actual problems that are on this notes page. And again, you don't have to print it out. You don't have to fill it out. You can just jot down whatever you need for help later. You know, whatever is the most way for you to really understand the material. All right. So the first thing on my page, and I'm at the very bottom, it says number 6 is continuation from yesterday in 13.0. It's got of C equals 1.3245. What that's telling you is that if you have the triangle, the angle C has a tangent, meaning the opposite over adjacent ratio, the fraction would turn into 1.3245. So you're asking like, what is this angle measure? Hi, Luke. So I would have to do tan inverse of that 1.324. Asking your calculator what angle would have that relationship for tangent. So second tan 1.3245, and I'm getting an angle measured of about 52.9 degrees, so around 53. That alrighty? Okay. And let's see. Then how about number 7? Same kind of thinking. It's telling you that the sine of the angle is 0.9761. So you already know the sine. You know that in this triangle, the opposite over hypotenuse has that relationship. So to find the angle, I would do sine inverse of that number. So if inverse or second sine 0.9761 is going to tell me that that angle has about a 77.4 degree measure. So we're not going to do problems like this very often. We're going to spend a lot more time using that to find parts of triangles that we don't know. So on the back, if you're following along with the packet, on the back of that page, we start seeing more of what looks like yesterday's homework. We've got a triangle and we have some information about that triangle. So for example, in number 8, 40, 42. And I'm going to mute you guys because some of you guys have a lot of background noise. But if you have a question, you can go ahead and raise your hand. Remember how to do that? Go into participants. And when you see your name down at the very bottom, you'll have the option of raising your hand. So, alrighty, this is asking me for this angle. So I do the same as I did yesterday. I label the triangle, opposite, hypotenuse, and adjacent. Then I'm going to choose based on that. And then I'm just going to use sine inverse, cosine inverse, or tangent inverse, depending on which two pieces of the triangle I already know. So in this particular case, I know the opposite, the hypotenuse. So that's going to put me in a position of doing sine inverse, asking my calculator, hey, what angle has an opposite of 40 over 42 for a hypotenuse? So I'd go to my calculator, do second sine 40 over 42, and I would find out that that angle is 72.2 degrees. And then 9 is the similar setup. And in number 9, I've got this triangle going on. 16 here, 30 at the bottom. Here's the angle I'm looking for. So since this one's across from it, that's opposite, and this one at the bottom is going to be my adjacent. So knowing that I have opposite and adjacent from up here, I'm still going to select tangent, but since I'm not looking for a side, I'm looking for an angle, I'm going to do tan inverse of my opposite over adjacent. So I'm looking for the angle that would have that relationship. So I'm going to do inverse tangent of 16 over 30, and I'm going to find out that my angle would be 28.1 degrees. So that's kind of where that's at. Do you guys, and I'm unmuting you so I can hear y'all, do you guys have any questions about that? Some of you towards the bottom are muted, and I don't know if that's your intention or not. I'm going to try to unmute you. Sometimes if you're using other stuff, it's going to automatically mute you. And you're always welcome to mute yourself or take your video off if you want to. But is there anyone that's got a question so far? Dead silence. Okay. So, what this is leading to basically is solving triangles. What that means is you got to find all of the angles and all of the sides. So what I always do is I always draw a triangle that's going to have um, be a right triangle. I don't care what the letters are. Really common is A, B, C. And what I always do is I make a list of the capitals and the lowercase. These are going to be my angles. These are going to be my sides. For what we're doing right now, which is trig, one of the angles has to be 90 degrees. And then keeping in mind, since we're doing right triangles, if this is going to be across from A, that makes it little a. Across from angle B would be side little b. Across from angle C will be the side C, which is a lowercase. So I try to remember what we talked about yesterday too, which is when I'm doing these and trying to find all of these pieces of information, these have to total 180 degrees. So if I know two of them, I can just use subtraction. I don't have to keep doing subtraction. And over here, I'm going to remind myself that a squared plus b squared equals c squared. So I can use that as a cheat to find the third side instead of always using trig. So say, for example, that they told us this was 90, and they told me this was, like we did before, a 7, and that this was a 12. I don't know this side, but I know that side A is 7 and side C is 12. So then this is the information I'm given, and I'm supposed to find the rest of these. Well, I already know 2 out of the 3 sides, so I really don't have to use trig. I can go ahead and use Pythagorean theorem. If I did use trig, I'd get the same answer. But I would do 7 squared plus b squared equals 12 squared, and then I'd skip doing the trig for that one. So if I do 12 squared and subtract my 7 squared, I end up with 95. And so the square root of that is going to put me at about 9.7. So that is just me taking 12 squared minus 7 squared and then taking the square root of that answer, which was a 95. So my sides are done. So when I'm told to solve the triangle, I'm just trying to find all the sides and all the angles. It doesn't really matter whether I find side A or B next, but I always like to rely on the thing that was given in case I made a mistake on this one. So what I'm going to do is go back to the given information and say, this is going to be the angle I'm looking for. Angle A is the one in question. Across from that is the 7, which is opposite. The 12 is the hypotenuse. So for me to find angle A, I know that I can do opposite over hypotenuse would be sine inverse of my opposite over hypotenuse. So now I'm learning, or excuse me, I'm doing what we learned today. I'm asking my calculator to find me the angle, so inverse sine, that has 7 over 12 as an opposite to hypotenuse ratio. And I'm getting 35.7. So then this is going to be 35.7. For my third angle, I don't have to do trig. I could, but I also could just say, hey, 180 is my total. I have 90 tied up here in angle C. I have another 35.7 up here in angle A. If I just subtract all of that, I'm going to end up finding out that that last angle is going to be 54.3 degrees. And you can always check your answers for reasonableness, because, is that a word, reasonableness? Because across from the largest angle, which is 90, I should have the longest side, my hypotenuse. Then this one is the middle in terms of the size of the angle. So this answer should be in between these in terms of value. And this is the smallest angle, which should then be attached to the shortest side. So that's solving a triangle. Does that seem like something you guys can manage? Do you have any questions? Yes, no, maybe? I'm unmuting. Some of you are trying to. Some of you are locked. Okay. Does everyone have like good idea of what's happening? No idea of what's happening?
I get it.
Yeah? Okay. So, looking at this one, there's a word problem on here, so let's go ahead and do that if you're following along. In number 11, it doesn't give you a picture, but for this entire chapter, your picture should be a right triangle because we're studying trigonometry. And then when you're done drawing a picture, you just pay attention to whether they're asking you for an angle or a side. That'll help you decide, am I using regular sine, cosine, tangent, or do I have to also use inverse? So here it says you're standing 15 feet from a telephone pole. So here's the telephone pole. Here's you. Here's 15 feet. We're going to assume the telephone pole is perpendicular to the ground. It says at the end of the wire suspension cable connected to the top. So this is the wire. The angle of elevation. Now listen up, this I talked about yesterday. You got to know this term. Angle of elevation. So there's going to be this term on the quizzes on Friday, and I want you to know what it means. It means up from the horizon or the ground. And in this case, we're talking about the ground. Like what's the horizontal? So they're talking about this angle right here. That's going to be the angle of elevation. It says if the angle of elevation to the top is 49 degrees, how long is the suspension cable? Well, this is the wire, so that's actually the question they're asking. So then you look and say, okay, they're asking me for a side, so I'm going to be using straight up SOHCAHTOA. I am not going to necessarily be using an angle. Excuse me, the inverse to find the angle. So I would say from here, this thing they're asking me about is the opposite, and this one is the adjacent. So adjacent and hypotenuse mean I would set up as cosine of 49, because I know the angle, equals the adjacent side, which is 15, over the wire or hypotenuse, which is x. So this goes back to refreshing your memory on yesterday. These two switch out, so I'd have 15 divided by the cosine of 49 for my answer. So I think nobody cares what the answer to that is, but I'll do it just for funsies. Okay, just in case you're worried, this is 22.8 feet. Actually 9 feet. Now, what if in this question they had said, hey, here's you, no offense on the drawing, this pole is 20 feet tall and you are 7 feet away, what is the angle of elevation? Well, now you're talking about 13.0 day 2, what we learned today. But you'd really do the same kind of thinking. You'd say this is opposite and adjacent. There's nothing here, so I don't care. And with opposite and adjacent, it becomes a tangent problem. But because I'm looking for an angle instead of a side, I would do inverse and then tell my calculator the opposite side is 20, the adjacent side is 7. So inverse tan 20 over 7 tells me that that angle of elevation would be 70.7 degrees. So just kind of go through whatever the question is and say, all right, first of all, what sides do I know? The opposite, adjacent, hypotenuse. What do I know? And then secondly, ask yourself, are they asking me to find an angle or are they asking me to find a side? Because then you can decide whether you're using straight up sine cosine or you are doing inverses to find an angle. And then don't forget your cheats. If you're looking for all the angles, the third one's easy to do by subtracting from 180. And if you're looking for your third side, you can do a cheat and use Pythagorean theorem. Is that all okay-ish? Now, that is all there is in 13.0, and technically we did it in geometry, but we're kind of obviously in a weird situation right now. So we're just doing that for the whole week. Today's IXLs will be on finding the angles and doing what we practiced today, but then the worksheet kind of mixes them together, and then the quizzes will have them mixed together. And some of the quizzes questions are going to be super easy, like cosine is what? Adjacent over hypotenuse, right? And obviously you have your notes there, you have any homework you've done, you know, in front of you, and so anything you've done is fair game. The only thing I don't want you to do, obviously, is you know, be on an app or something that's helping you figure it out. You want to use some integrity and just practice what you're doing. Do you guys have specific questions on these, or should we try to see if we can get onto IXL and look at what you got to do?
I have a question about the IXL things.
Yes, ma'am.
So like when it's like it says what we have to do and then it says in parentheses out of 9, what does that mean?
So, and I think we talked about this before you got on today, Kelsey.
Sorry.
And that's okay. On the, oh, hang on, I'm gonna stop the recording. Nobody cares about this part. Bye, everybody.